want to welcome everyone. And get started. Thank you all for coming to this latest Congressional Biomedical Research Caucus. It's my pleasure to welcome you. I'm Joan Goldberg, Executive Director of the American Society for Cell Biology, one of the groups that makes up the Coalition for Life Sciences, which helps support this Congressional Biomedical Research Caucus. This caucus is the longest continuing caucus of its type. Today's speaker is Dr. Amy McGuire. She's an assistant professor of medicine and medical ethics at Baylor College of Medicine. She holds both a JD degree from the University of Houston and a PhD in medical humanities from the University of Texas Medical Branches Institute for the Medical Humanities. Her research addresses the legal and ethical aspects of genetics and genomics. The NIH has played a critical role in the mapping of the human genome. The 13-year project and the NIH funding that made it possible are to be commended for the incredible scientific advance that was once thought impossible. This research now enables scientists to focus on understanding the mutations in our genes and how they can give rise to disease or disorders and how such conditions may be short-circuited or treated. One of the other things that scientists are enabled to do by the research and the ongoing research is to try and translate some of the basic findings into clinical practice and into what's been called personalized medicine. Dr. McGuire will present on the impact of such research advances and the challenges to be overcome with this kind of research. And I'd like to welcome Dr. McGuire.
Thank you, Joan, and thank you very much for inviting me to be here today and for taking time out of your busy schedules to be here today. I'm really excited to talk to you about some of my research and work on thinking about the issues related to the future of personal genomics. Let's see if I can figure this out. There we go. So in the not-so-distant future, we can expect to walk into a physician's office for an annual physical and walk out with a blueprint of our genetic inheritance and with the knowledge of the most likely cause of our own death. For many, this is the vision of the future of personal genomics. And if you look at this or read this, you might think that it was published last week or last month. But actually, this is from a New York Times article that was published almost 19 years ago. And I think that this is still the vision of the future of personal genomics. While we've come much closer to achieving the first aspect of this vision, which is being able to get a blueprint of our genetic inheritance, we still have a long way to go to really understand what the significance of that genetic information is for our future health. And so what I'd like to talk about today is three different things. I'd like to talk about the current state of personal genomics in two areas, the area of biomedical research and then sort of the parallel area or developing area of direct-to-consumer personal genome testing. And then I'd like to talk about what we all hope for, which is the goal of integrating these two areas or advances in these two areas into the clinical care. So let me start with biomedical research. And in the area of biomedical research, there's many exciting initiatives that are currently underway, and I think that they can broadly be categorized into two major groups. The first are those types of research projects that are primarily intended to advance technology and develop or build shared resources. This includes many different types of large-scale sequencing projects as well as personal genome sequencing initiatives. In the area of those types of studies, the second group, which is those types of studies that are really aimed at studying the functional significance of human genetic variation, we have many genome-wide association studies as well as developments in the field of pharmacogenomics. So over the past 20 years, since the beginning of the Human Genome Project, there has been tremendous technological advance in our ability to sequence DNA. Just to remind you, the Human Genome Project started in 1988. It was a massive international collaboration that was aimed at developing a reference genome from multiple individuals across the globe. And it took 13 years and $2.7 billion to complete. So it was a major initiative. Building on the resources from the Human Genome Project and other large-scale sequencing studies that have come after it, we've advanced the technology and decreased the cost to such a point that within the last year we saw the first individual whole human genome sequences complete. And the first two sequences that were complete were those of Dr. James Watson, who's up here. Dr. Watson, of course, was one of the co-discoverers of the structure of DNA in 1953 with Francis Crick. And on the other side of the screen, we have Craig Venter, who's also a very well-known scientist who led the private initiative to complete the Human Genome Project. And just to illustrate how far we've come with regard to our technological advance, whereas I mentioned before that the Human Genome Project took 13 years and $2.7 billion to complete, Dr. Watson's genome was sequenced in about a month for about $1 million. There's also been tremendous advance in our ability to understand human genetic variation, and the journal Science had as their breakthrough of the year this past year, human genetic variation. And this is because there have been hundreds of genome-wide association studies that have been published that have looked at particular genetic variations and their association with particular phenotypes, typically related to common and complex disorders, things such as coronary artery disease, rheumatoid arthritis, hypertension, diabetes, bipolar disorder, and many, many others. Finally, there's tremendous excitement in the area of pharmacogenomics. Pharmacogenomics aims to look at human genetic variation and how it affects individuals' ability to metabolize certain drugs or the differences in individuals' response to certain drugs. And there are many examples of advances in pharmacogenomics. I have up here just one example. This is with the drug warfarin, which is an anticoagulant. And it's very difficult to prescribe warfarin to patients and to dose them appropriately on it because people respond very differently to different doses of warfarin. So you're always trying to adjust the dose of an individual, trying to get the right dose for that individual. Well, recent research has shown that there are 2 different genes that have been shown to be associated with variation in individual response to warfarin. And so within the last year, the FDA has approved label changes to warfarin that actually includes information about these genetic tests and the association between genetic variants in these gene regions and responses, individual responses to warfarin. And I think this raises a really interesting question that we can discuss later, which is whether this is going to change the standard of care in medical practice with regard to doing genetic testing prior to prescribing warfarin. Currently, it's not the standard of care to do a genetic test prior to prescribing warfarin, and for good reasons, one of which is the cost of the genetic test. But it raises a really interesting question about what will drive the standard of care with regard to genetic testing in medicine. So now I want to move to sort of that parallel field that I was talking about, which is direct-to-consumer personal genome testing, and talk a little bit about some of the initiatives in that area. Over the last year or two, there have been several companies that have been launched that offer personal genome testing direct-to-consumer. You may be familiar with some of these. This is just a couple up here. 23andMe is one of the most well-known ones because one of the co-founders of 23andMe is the wife of the founder of Google, so they have a tremendous visibility as well as financial backing. And these companies vary significantly in the services they provide and the tests that they do, but basically the idea is that you send them a sample of your saliva and about $1,000, and they'll sequence a portion of your genome, they'll put it out on the internet for you to explore and interact with. There's many things you can do with it. You can do ancestry tracing, you can sort of Google your genome. If you see a new report about a genetic variation that seems interesting to you, you can see if you have it. Some of them have even talked about doing things like social networking on the basis of your genome. So one of the most controversial questions with regard to these direct-to-consumer personal genome testing companies is whether or not they are actually, what kind of information they're providing, and whether or not they're actually providing medical diagnostic information. Again, the companies vary significantly in how they approach the information that they're providing. Navigenics, for example, which is one big company, advertises that it's providing information for you to make, to understand information about your health. They provide a physician who orders the test. They provide post-test genetic counseling. However, they explicitly state on their terms of service on their website that providing these services does not create a physician-patient relationship between the provider that they provide and the consumer. And they also explicitly say that the services they provide are for informational purposes only, and you should not make healthcare decisions on the basis of what you're getting back from them. 23andMe, on the other hand, explicitly says that they don't provide medical advice, and their services can't be used for health ascertainment and disease purposes. They warn consumers on their website that reliance on any of the information provided is solely at the consumer's own risk. So I think this raises really interesting questions about what is the information that they're providing and how are consumers going to interpret that information. And if you look at what they're actually testing for, this is a chart that I know you can't read, but it was put together by the Genetics and Public Policy Center that Kathy Hudson is the director of. And it lists over here all of the companies that are offering direct-to-consumer genetic testing, and across the top it lists all of the traits that they are testing for. And you can get a general sense just from the shaded boxes that all of these companies are offering many different types of tests. None of them test for every single thing on this list, and there's great variation in sort of the amount of things that they're testing for and what they're testing for. The first column here, the shaded boxes show those companies that offer personal genome testing services, so kind of a broader scan of your genome. If we look more closely at what some of these traits are, though, that the companies are testing for, we'll see that they are testing for things that show risk associated with things like Alzheimer's disease or addiction, Parkinson's disease, multiple sclerosis, arthritis, diabetes, obesity, infertility, cardiovascular disease, cancer, and many, many more. So even though these companies are saying they're not providing health information to consumers, there is the concern that because they're testing for risk susceptibility to these types of health conditions, that people may misinterpret the information and the clinical utility or significance of the information that they're getting. One of the reasons that we're so concerned about this is that research shows that people understand risk information very, very poorly. So they tend to see it as either 0% or 100%. And this might lead to what we call genetic determinism, which is the idea that you tell somebody you have a genetic variation that has been shown to be associated with an increased risk of cardiovascular disease. And they interpret that as, I am going to have a heart attack and die. So we have a concern about the tendency towards genetic determinism, and I think that this is really reinforced with some of the messages that we see in the popular press. And all you have to do is look at the cover of Time magazine to understand what I'm talking about. This is one of my favorite Time magazine covers where it suggests that we have an IQ gene. And if we could just get tested for that gene, you would know if you or your child or your fetus or your embryo is going to be smart or not. This is obviously a big misconception with regard to where we are with the science for this very complex trait such as IQ. And this kind of information or message is being sent out to the public not just with regard to traits such as medical conditions or even IQ, but even behavioral traits. One of my favorite Time magazine covers is this one, which says, infidelity, it may be in our genes. And I think this may be a convenient excuse for some, but it certainly isn't scientifically accurate. I actually showed this slide one time at a talk that I gave, and one of the audience members came up to me afterwards, and I made what I thought was a very clever comment, which was that with regard to infidelity, it's not what's in your genes that counts, but what's out of your genes. But this is clearly illustrates, I think, the problem of genetic determinism and the problem of consumers and patients misunderstanding the information that they're receiving from personal genome testing companies. So one of the things that this leads us to, one of the questions this leads us to, is whether we're going to have a premature integration of personal genome testing into clinical care. And the reason we worry about this is because if consumers are getting information, regardless of the caveats on the website about not using this information for diagnostic purposes, not making healthcare decisions on the basis of it, if they're getting this information and it's giving them risk information about things that might be related to their future health, they're going to have questions, they're going to be confused, and they're probably going to turn to their healthcare providers. And in fact, many of these companies on their websites actually advise consumers to seek the advice of their physicians if they have any questions. On the other hand, the advice that physicians are getting is quite different. In a recent commentary published in the New England Journal of Medicine, David Hunter and his colleagues advise physicians that if they have patients who come to them with questions about their personal genome test obtained from one of these companies, they should simply provide the patient with a general statement about the poor sensitivity and positive predictive value of the results. And the reason that they provide this advice is because they're concerned about the validity of these tests and they're concerned about the utility of the tests. With regard to the validity of the tests, there's a lot of concern that the test is not accurately or reliably testing what it says it is. And this can, I think, be addressed through increased regulation, making sure that these tests are done in certified and CLIA-approved laboratories. There's been a lot of discussion about increased FDA regulation to ensure safety and efficacy of the tests. There's also concern about the clinical validity of the tests, and this is because a lot of the research that's being done that these tests are based on is preliminary research. It may not have been validated. It may not have been done with large enough cohorts to ensure that there's power to really know what the validity of the tests are from a clinical perspective. There's a reason that we don't just jump from bench to bedside without some transition, and this is kind of bridging that transition. With regard to the utility of the information, I think it's very important for people to understand the difference between what is statistically significant from a research perspective and what is clinically significant. So we might get very excited in the research field that we found a statistically significant association between a particular genetic variant and a particular phenotype. But that may have no clinical significance whatsoever for an individual patient. So for example, in the area of cardiovascular disease, there have been a lot of reports showing genetic associations with variations on chromosome 9. And they've been shown to be statistically significant variations. So individuals have an increased risk of developing heart disease if they have this particular genetic variation. Very, very interesting and very exciting from a research perspective. From a clinical perspective, what that may actually mean for an individual patient is whereas you might have had an overall lifetime risk of developing heart disease of 1%, now if you have this genetic variant, your risk of developing heart disease over your lifetime increases to 1.6%. So how are we supposed to use that information to make informed decisions about our medical care, follow-up diagnostic tests, preventive treatment, et cetera? So I think that this advice to physicians is actually very warranted on the basis of these concerns about validity and utility. However, I worry that they may be inconsistent with potential patients' or consumers' expectations of physicians in this area. So we recently did a survey. This hasn't been published yet. We're still writing it up. But we did an online survey of registered users of Facebook.com, which is a very popular social networking site. You can see from our demographics that this is not a representative sample of the U.S. population, and we were not aiming to achieve a representative sample. What we were trying to do is to target that demographic that we thought might be among the first wave of users of personal genome testing services. So our total sample was 1,087. Our median age was 35 with a standard deviation of 12. 83% of our respondents were Caucasian, 73% were female, and 60% had at least a college education. We asked the respondents how many of them had used personal genome testing services or would consider using personal genome testing services. We found that 6% of the respondents had actually used these services, which was, given how new they are, it was kind of a surprise. I think it sounds small, but it's actually quite a large number. 64% said they would use these services, and 30% said they would not use personal genome testing services. We then asked those who said that they would consider using these services why they would use them, and they could choose more than one reason. Just over 80% said they were just generally curious about their genetic makeup. So they had general curiosity. 74% about said that they wanted to see if a specific disease was in their family or was genetic. So they were specifically using it for a medical purpose to find out if a disease was in their family or genetic. And 40%, interestingly, wanted to learn about their genetic makeup specifically without having to go through a physician. For those who said they were not interested in using these services, the reasons that they cited was because they didn't think the information would be useful, about 54%. 40% or so were concerned about the cost, and again, the cost varies, but average is about $1,000 for one of these tests. And just over 20% were concerned about their privacy and concerned about the return of unwanted information from these tests. Next, we were interested in finding out how many of our respondents considered the information that they got back from these tests to be a medical diagnosis. There's a big controversy legally now about whether this is considered diagnostic information. New York and California have both sent out cease and desist or warning letters to many of these companies saying that they are in violation of state law for the unlicensed practice of medicine because they're providing medical diagnostic information in the absence of a physician-patient relationship. So we were interested in finding out what consumers thought about this information with regard to whether it was diagnostic. Of those 6% who had actually used these services, 60% of them felt that the information they got back was a medical diagnosis. Of those who said they would use the services, just under 40% thought they would be receiving back a medical diagnosis. And of those who wouldn't use the services, about 22 or 23% felt that they would be getting back a medical diagnosis from the test. Finally, we were interested in their expectations of physicians with regard to helping them to interpret information from these personal genome tests. And we asked those who had used these services, that 6% of our sample population, whether they had spoken to their physician about their test result. And about 55% said that they had spoken to their physician about their test result. A little bit more, about 10% said they planned to, but they hadn't yet spoken to their physician. Of those who said they would use personal genome testing, almost 80% said that they would talk to their physician and ask their physician for help in interpreting the results of their personal genome test. And of all of our respondents, we asked them if they felt that physicians had a professional obligation to help individuals understand test results from these personal genome companies. And you can see that just over 60% of our sample agreed or strongly agreed with the statement that there is a professional obligation to help individuals understand these results. So I think because this is not a representative sample, obviously this doesn't tell us about what the general US population thinks of these tests. But I think that we can conclude, at least among our demographic, that there's a potential disconnect between patient expectations about the clinical integration of personal genome testing and the advice that's being given to physicians about advising patients or helping patients interpret this information. So just to conclude, I kind of want to summarize the 3 different areas that we were talking about and where I think this leaves us. I would say that research in this area, in the biomedical research field, is progressing at a very fast pace, but there's still quite a lot more to do. For better or worse, I think that this parallel field of direct-to-consumer personal genome testing is pushing the clinical integration of personal genomics, and that this is going to create many challenges and require major reform. And I just want to leave you with some thoughts about some of the areas where reform may be necessary for us to think about. One of them is in the area of education, and there are several initiatives that have started to think about widespread and large-scale public education about genetic information and what that means and risk information in the context of genetics, but I think a lot more of that is needed. Also, with regard to healthcare professionals, studies suggest that most, at least primary care physicians, do not feel like they have sufficient knowledge about genetics to advise patients on the basis of even single gene testing, let alone these large-scale genome-wide information scans. So I think there's need for additional education for healthcare providers about genetics and the meaning of this information. In the area of research, multidisciplinary research is certainly necessary to advance the science and help us continue to increase our understanding of what this genetic variation means and what are the sort of biological pathways behind this genetic variation and its association with particular phenotypes. Also studying sort of the ethical and legal and social implications of this, I think, is ultimately very important. And outcomes-based research to see if, as we start to integrate this into clinical care, is it actually improving the care that we're providing to patients? There's certainly need for reform in the area of reimbursement. I think there has to be clear standards and guidelines so that we can avoid tests or follow-up treatment that are not medically indicated. I think that the tendency is going to be for physicians to diagnose, provide follow-up care out of concern that they're getting information from these companies that may not be reliable. It certainly may not have utility, but somebody's coming to them with it, and so there will be a tendency to practice defensive medicine, and we want to try to avoid that if it's not medically indicated. As medical research advances, hopefully, we will gain additional knowledge that will make some of this information more useful from a clinical perspective. And as that happens, we certainly need to make sure that there is access and reimbursement for the patient education that's going to be required, as well as for the medically indicated tests and treatments and follow-up preventative treatment or care that's provided. And finally, I came into this with an interest in ethics and patient protection, and I still think that there's a lot of work to do in that area. I would say that increased regulation is probably warranted, at least to avoid false or misleading advertising in this area, also to ensure safety and efficacy. There needs to be informed consent before people go out and start getting personal genome testing to satisfy their curiosity or for whatever other reason they're interested in it. And finally, there certainly needs to be increased privacy protection, especially as we move towards an integrated electronic health system or health record system in our country. And I just want to end by making some acknowledgements. I don't do my research in isolation, as none of us do, and so I am funded by the NIH NHGRI program, their ELSI program, and the Greenwell Foundation Faculty Scholars Program in Bioethics. And I have many collaborators who have helped me with my research and also helped me to develop some of my thoughts in this area, so I want to thank them as well. Now I will open it up for questions. Thank you.
I'll start with one. You talked about what New York and California were doing in terms of cease and desist letters for some of the companies that are doing private genetic testing. What about the FDA? Is the FDA focusing on the direct-to-consumer advertising or regulating these tests in any way?
Yeah. So there's been a lot of discussion about FDA regulation of these companies, and I think that we were just talking that might be the sort of next big legislative action that comes. And there's been some reports that have been done looking at the companies. The FDA, there's been discussion about whether the FDA has jurisdiction over this and whether they have appropriate staffing to actually, if they decide to regulate this, to actually follow through with that. So that's currently in discussion. A lot of people have pushed for increased regulation of this, and we'll have to just sort of see where that goes. But yeah, that's certainly been a big part of the discussion.
So most of the people in your study were talking about testing for themselves personally. What are your thoughts and implications for testing of your children or someone else's children?
So we actually asked them about that. This was a very brief overview of many different issues, so I apologize of not going into depth on any one of them. But we did ask them about that. Most of these companies allow individuals to test their children. And a lot of the companies, if you look at, if you're interested in this, you should kind of peruse their websites. It's quite interesting. But some of them say you shouldn't test children, although there's really no way of making sure that you don't send in a sample from your child. Others explicitly say you can send in samples from your children. Some websites give warnings, like if you send in a sample from somebody under 2, you may not get enough saliva to actually do good testing. But they do allow it for the most part. We asked our survey respondents what they thought of that. We asked them if they would test somebody other than themselves, including a spouse or significant other, and including their children. And a large number of them did say that they would be interested in testing their children. And there was a statistically significant correlation between those who said they would test their children, and the reason that they gave was to test for a specific disease or condition. So they were looking for something specific with regard to their children. We also asked them more generally whether they thought these companies should allow people to test their children, and the majority of our respondents agreed that the companies should allow testing of children. Now, I think this raises really interesting ethical questions. The current guidelines on testing children for adult-onset disorders is very conservative and suggests that you shouldn't test children for good reason. One of the reasons is an autonomy-based concern that many people might not want this information about whether they have a susceptibility to Alzheimer's disease or Parkinson's disease. And so we should let children reach the age of majority, which is typically 18, and then let them decide for themselves whether they want this information. After all, there's nothing you can do about it really in the short term if it's a late onset disorder. So this kind of cuts against the grain with regard to the current guidelines for genetic testing in clinical medicine. There has been some discussion in the ethics literature about whether those guidelines, which are really kind of based on a risk-benefit analysis and an autonomy-based analysis for children, are appropriate, or should we give more credence to parental authority to make decisions on how to rear their children, as we do in many different areas like education and things like that. So there's sort of that debate going on right now, but that's a really good question.
Yeah. Excuse me. We already know that some diseases or conditions tend to run in families. I mean, and doctors know that, like heart disease, breast cancer, things like that. Are these tests adding much more information than that? I mean, if your mother and her sister had early breast cancer, do you get much more information from this than you have from just knowing that your mother and your sister and her sister had breast cancer?
Well, I think it depends who you ask, and it depends what test you're talking about or what condition you're talking about. So some would argue for these very common and complex disorders, certainly family history information, environmental exposures, lifestyle and behavior, diet, exercise things are much more useful information for understanding how to tailor a treatment or prevention plan for a patient than this information. Breast cancer is a really good example because we have many years of experience where we have a genetic test for like the BRCA genes that provides information. But even in that context, if you talk to oncologists who do breast cancer research and treat patients with breast cancer, they oftentimes don't know how to use that information to make recommendations for treatment, because it's somewhat useful from an informational perspective, but it may not tell the whole picture, and it certainly doesn't direct care in a particular area. One of the concerns, I think, is that people are going to overinterpret this information and rely on it too heavily. And that goes in both directions. So I talked about genetic determinism, which is if I have it, I'm doomed. Oh, well, I might as well, not do anything, or oh my God, I've got to go on this crazy diet or whatever. The opposite is I don't have it, so I'm safe. Let me go ahead and smoke a pack of cigarettes a day, or which is obviously not good advice for anybody. So a lot of people argue that really the type of advice you'll be giving patients on the basis of this information, like live a healthier lifestyle, don't smoke, exercise, eat healthy, are things you'd be telling them anyways.
Would you say one more word about educating physicians about what, you said there are some initiatives. Could I just have, for instance?
Well, I think there are initiatives on different levels. I know at some institutions there are initiatives, like there's been a lot of discussions at my institution, I can speak most authoritatively about that, about integrating genetics education more throughout starting with first-year medical students. There's been discussions about, at the residency level, we haven't done this yet, but there's been discussions about having sort of tracks through all residency programs to address certain topics. Genetics would be one of those. And then I think the NIH, some of the work groups I sit on for the NIH or the Department of Health and Human Services have talked a lot about sort of what are more sort of national level education activities that we can do, continuing medical education programs, things like that. So I think it's happening at all levels. Yeah.
So instead of marketing directly to consumers, do any of these companies try and get around these legal what is or what is not, what are they offering or what aren't they offering, by actually offering their services at the request of physicians?
Well, so these companies, so I guess the closest to that is probably Navigenics and that approach, which is to hire a physician to order the tests, and they explicitly say on their website, we're doing this to comply with state law, but this does not create a relationship with the physician, which is interesting. So it raises interesting questions about sort of, if you have a staff physician who's ordering the test routinely for everybody, and you have some sort of surface general genetic counseling for individuals, post-test counseling, but you don't have a real physician-patient relationship, and you're not taking a detailed family history, you're not sort of you're not seeing the patients, you're not doing a physical exam, is that an appropriate use of the healthcare profession, or does that simply legitimize something that shouldn't be legitimized from the perspective of being integrated with medical care? I don't know. I don't think any physicians would order this type of test for their patients, but again, this is something that I think people are thinking is in the near future, where we'll get to the point where it will become useful to order these tests. Now, there are sort of large microarray type of tests that are being done. Baylor's one of the places where we're developing this, and they provide a significant amount of information, but I think that the groups that are doing this from within the profession are being a little bit more cautious about what information they provide back and making sure that it's really been validated and there's utility to the information that they're providing back. So it's certainly developing and developing quickly. And it may get to a point, because the technology is advancing so quickly, that it actually becomes cheaper to do large-scale sequencing tests as opposed to several different individual genetic tests, in which case you'll have a ton of information that may not mean anything, and then the question is whether you give that back to the patient or not. Yeah.
Problem with any kind of large-scale database is the accuracy of the data. What do we know about the accuracy of the sequencing that's being done? Incidences of false positives and false negatives, how precise is the sequence determination? If you're going to use the information, it needs to be right.
Right. So that was one of that question of sort of the analytic validity of the tests is what you're raising. And I think it depends on the groups. With any laboratory tests, you're not 100% sure that you have the right specimen or that the laboratory is doing the work that they're doing. With regard to where we are with the technology, I think it's possible to get a pretty low error rate, but I'm not sure that that's actually routinely done with these types of tests. So I don't actually know scientifically what is the error rate when you're doing this type of sequencing. That would be a question for one of my colleagues in the sequencing center. And I certainly don't know with regard to these companies what the ins and outs of their processing procedures are and what their error rates are. But I'm sure you could get that information. But that's an important question to ask about. Yeah?
What about the privacy issues?
What about the privacy issues? Generally?
Yeah,
Or-
well, these companies get this information
Yeah.
from people and what they do with it and how they use it.
Yeah, so there seems to be a disconnect that a lot of people have documented between people's concern about privacy and their actions. I mean, we put out our credit card information, our social security, and everything all over the place, although we say we're very concerned about our privacy. And I think this is another example of that, which is I think people are concerned about their privacy. All of these companies have privacy policies. They've certainly thought a lot about how to protect privacy. What happens if one of them goes out of business? Where does the information go? These are the sorts of questions, error rates, privacy policies, that informed consumers really need to be asking about before they decide whether or not they want to use these services, and if they do, which company do they want to use, because they vary depending on the company. But I think privacy is a big issue. Yeah.
Would you go a little bit over into the ethical realm and talk a little bit about what my responsibility is? Say I'm a consumer for this, but I'm closely related to my siblings. And my information is in some sense actually physically tied to information about them. What are my rights and responsibilities as an individual to my siblings? And I feel quite differently about the sneaking up on my husband for some saliva or doing this for my 9-year-old, but considering a peer group of siblings, what are my responsibilities ethically to them?
So this has come up in several different contexts sort of that we can draw from. One area is kind of in the context of the physician-patient relationship with regard to if you do genetic testing, is there a duty to warn a relative who might be at risk? And the general guidelines for that have been that while the individual might have a moral obligation to talk to their family members, that I found out I have this, there's a very good chance you might have it, that sort of thing. It hasn't really been extended to professionals in the sense of breaching physician-patient confidentiality unless there's good reasons to, like there's an identified person and there's a high risk of harm and there's something that you could possibly do about it. Those are sort of the guidelines that we have right now with regard to that. The other consideration that you want to think about is not everybody wants this information. And so it may be that you're interested in finding out stuff about your genetics, but your sister doesn't want to know if she has a predisposition to breast cancer or Alzheimer's or whatever. So there needs to be that conversation with family members for sure about, I'm planning to do this. Do you want information about this if I find something out or not? And how can I protect your privacy? This has also come up kind of in a much more imminent way in the research field when we're doing whole human genome sequencing. So I mentioned Dr. Watson and Dr. Venter. Dr. Watson's genome was sequenced by 454 Life Sciences, which is a company that developed a sequencing technology. It was analyzed at Baylor College of Medicine, so I was a collaborator on that project. And one of the main ethical issues we struggled with is both of their genomes are out on the internet. And they're identified, because everybody knows this is Dr. Watson. You can actually Google Jim Watson's genome and pull it up. And there was a lot of concern about his obligation to his close genetic relatives, his children, his siblings. You know, I don't think he has parents. Yeah, he definitely doesn't have parents alive. But you know, I don't think he has siblings. But it was mostly his children that we were concerned about. So we were kind of dealing with sort of the dual question of what is our obligation as researchers and healthcare providers to his children, and what is his obligation as an individual and citizen to his family members. We kind of got around, and we were mostly concerned about it in the context of it being publicly accessible, because then you really have a privacy issue there. We got around that issue by, and this could only work with Jim Watson, which is we didn't release his data into the public, he did. So it put the onus on him. It certainly doesn't do away with the moral question of what's his obligation. And he did not want to talk to his children about this at all. So he didn't. Is that right or wrong? I mean, I think that's something that needs serious consideration. With regard to these companies where it's not public and the privacy risks aren't as great, I think the real issue is, do they want to know this information or not? The other thing we need to take into consideration is the very high rate of non-paternity in this country. And this kind of test certainly could reveal information about non-paternity that may not be wanted information. Yeah.
In your professional opinion and what you've gotten from the research, can you kind of set up a rough outline of when you see this being a widely accepted medical practice, as opposed to, you know, a whim of someone who can, you know, use just spend $1,000 on something they have on the internet, like a full body scan used to be. This kind of, not necessarily just a whim for the rich, but more, something that everybody gets done.
Yeah, I think it depends on who you ask. But the estimates that I've heard from my scientific colleagues is that within about 5 years, we'll be able to sequence an individual genome for almost $1,000, 5 to 10 years. At that point, I think it comes back to the issue of, is it cheaper to do that test than to do a test for BRCA and the individual gene tests that we know have clinical utility. So I think the way that it will get integrated into clinical care is not because we think all of this information is useful, but there's pieces of the information that's useful, and it's cheaper to do a whole genome scan on an individual than to do targeted genetic testing. And so we generate information sort of as a byproduct of that, and the question is what to do with that information. So I don't think it'll be long before this is used, but it will be used for a different purpose. And then, of course, the direct-to-consumer thing, it depends on how successful the states are in trying to stop some of what they're doing, and it depends on how much we have regulation of it, and it depends on how many people are actually decide to use these services. A lot of people in our survey said they were interested in it. That doesn't mean they're actually going to go out and do it. So there needs to be additional research on that. Yeah.
Back on the kind of quality and reliability idea, do you know if anybody's taken that plethora of companies and done a kind of a Consumer Reports type, send the same sample to 20 of them and see whether you get a standardized answer or not?
Yeah, good question. So that would be a great idea. The Government Accounting Office has done something similar to that, but it was I think a year or two ago, and it was kind of before these whole genome scan companies, personal genome testing companies developed. So it was mostly with companies that do what's called nutrigenomics. And these companies, you send your sample, they genotype you, and then they give you nutritional advice on the basis of what they find, and then they usually sell you vitamins and things like that on the basis of it. And they found that they sent the same sample to multiple companies, and they got back totally different results. And so this is sort of, their report has sort of led the discussion about increased regulation. But it hasn't been specifically with these newer generation of companies. It was more with the companies that do things like nutrigenomics. So that certainly would be interesting to repeat with some of the newer companies that are claiming that they can be more reliable and that they're really following scientific standards for testing and things like that.
There is a tiny bit of data on that.
I'm sorry?
There is a tiny bit of data on that. I heard a talk yesterday from David Duncan, who is a science journalist who's writing a book. It's going to be out within months, called The Experimental Man. And he sent samples of himself to a whole bunch of the different companies. And he writes a book about what he learned and et cetera, so I won't go into it. But one of the things he did find was that these different companies, 23andMe and various other ones, their results were very, very close.
Yeah.
Very close. Which would indicate that their testing was reliable.
Yeah. Yeah, and I think it depends on what companies you're looking at, because they've also done a little bit of that with the companies that do ancestry tracing, and they found a lot of variability in what you're finding with regard to ancestry tracing. So, that's an interesting area as well. There's such a desire for connection with people that people are hooking up through these ancestry tracing that we might have come from the same village or tribe or things like that. Yeah.
How these whole genome scan companies interface with the companies that do individual genetic testing of genes, and maybe they own the patent on that gene, and how does that information, so if you're doing a whole genome scan and then another company has a patent, how does that all work out in the marketplace?
Very interesting question, and I don't know the answer to it, and I don't think it's been challenged, but it's a very interesting question, and it will become an interesting question as this gets integrated as well. There's been some discussion about people who are doing this a little bit with the microarray stuff about, are we violating patents by testing certain gene sites? Nobody has challenged it yet as far as I know, but it could have dramatic effects one way or the other depending on how that comes out. So that's a really interesting and important question. Yeah.
Could you explain a little more what you meant by defensive medicine and doctors overdiagnosing certain diseases because maybe they don't believe in these genetic testing, the reliability of them?
Well, so I have a law degree, so I can't help but think, what a great lawsuit when I think about some of these things. So you can imagine, right? I told you, and I'll use this as an example, with pharmacogenomics, that it's not current standard of care to test somebody for one of these gene variants before prescribing warfarin, for example. What a great lawsuit if you prescribe somebody on a dose of warfarin, they have a significant negative reaction because it's the wrong dose, which is, it's very difficult to dose people on warfarin. They later get a genetic test that tells them, if you had this information, you could have more accurately dosed them on warfarin, so you should have done the genetic test. Concerns about that happening might lead to what's called defensive medicine, which means that we do things that may not medically be the best thing for us to do or make the most amount of sense, or from a consideration of allocation of scarce resources, we should not be spending our money on that, but we're concerned that it's going to eventually lead to a lawsuit if we don't do it, so we do it anyways. And I think there's a real concern in this area. We have millions and millions, 43 million Americans who are uninsured. I mean, there's major problems with access to basic health care. And there's a lot of questions about whether we should be putting our money and our resources towards this type of genetic testing when the yield may not be what it's worth at this point in time. Yeah?
Bringing, I guess, the topic back to the researchers, you have all these companies that now have these wealths of data, single nucleotide polymorphisms. How are researchers able, or are they able to access that information to come up with new studies and correlations based on...
You guys are good. You've asked like every question that I thought. So yeah, that's good. That's a great question. There is a lot of, and this is one area that I've been thinking a lot about and writing about right now, which is what are sort of the risks and opportunities for collaboration with biomedical researchers in this area. Many of the companies have specifically sought out to foster research collaborations. 23andMe, for example, I think there was a recent news article talking about their collaboration with the advocacy group for individuals with Parkinson's disease, I think, and there's been some discussions, I think, with different groups, autism, things like that. So it's more driven from patient advocacy groups, but there's a big question about, but I think a lot of these companies have an incentive and are really motivated to advance research. That's certainly one of their goals. And so I think there needs to be more thought about what are the risks of collaborating with these companies. They are developing huge resources. Who owns those resources? What are the implications of that for IP, intellectual property issues? What are the implications for who directs research questions? There are some patient advocacy groups that may not be, the research that they're interested in may not be done because it's not really fundable because it's such a small population of people with this disease, or they may have research questions they want answered, and can they direct where the research is going by collaborating with these companies and basically paying for their own sequence and then collaborating with researchers who can use that information to do what they are interested in having done. So yeah, that's a really important point and a great, I think it's going to be much more talked about in the near future. So yeah. Other questions? You got a time, or let me take one?
One more? Okay.
Okay.
Could we tinker with this kind of technology and try to make a person who couldn't get a disease or something?
So,
because I heard that nowadays you can try to determine the sex of your child before they're born or something.
yeah, so a lot of the ethical issues dealing with genetic testing prenatally bring up these issues of how much should we do to sort of choose what kind of child we want born. And there's a lot of people now, if you have a predisposition to a serious genetic condition, you can do what's called pre-implantation genetic diagnosis, where you do in vitro fertilization, and you can take one cell out of each embryo and test it for a variety of genetic conditions and then choose those embryos that are the healthiest embryos. And so a lot of the discussion is how far should that go in being able to choose the sex of your child, to choose other types of traits that may not be life-threatening. Certainly, disability rights organizations have a lot to say about this. There's been even some discussion about the ability to choose. We had an interesting case discussion at a children's hospital recently about somebody was requesting in vitro fertilization and pre-implantation genetic diagnosis to select embryos that had a particular condition, like in this case it was for a particular form of dwarfism, because both of the parents were little people and they wanted a child who was the same stature as them. should you be able to do that? So there's a lot of questions about whether that should be ethically appropriate or not, and how we should direct those questions. And that's been around since we've started doing, the field of genetics, but it certainly becomes more salient as we develop in this research area. Okay, thank you very much.